So you guys are able to see the screen, right?
Yes, sir.
Okay, good. So let me this. So the other day, right, we had looked into some of the concepts here, like what are variables and what are the identifiers, how do you name a variable, and what are the rules associated with naming a variable, and how do you assign a value to a variable using the equal to symbol, right? Name is equal to object. Where, why are we saying it is equal to object? Because everything in Python is an object. That's what we want to see again in this session today. So let's straight away jump into what is known as Python variables are kind of a pointers. Let's see what it means. All right. Let me zoom a little bit. All right. So as you have seen, right, in other programming languages like C, what you usually used to do, uh, we used to say that variables are nothing but the containers or the bucket for storing the data. That is what we used to say it as. Okay. Now, what it means is uh, you have a variable name, and each variable name can be of a number, or it can be of a date. It can store a location or anything, or an average value like a decimal or floating number. All right. So now, what it means is in other programming languages, okay, this is, we are talking about C, or for that matter statistically typed programming language, where we used to say like, okay, int num is equal to 24. What we are saying is we are defining what kind of a variable it is. It is of an integer type, and then it is name, that the variable name is number, and the value assigned is 24. All right. So now what happens is the variable name would be 20 number, and the value assigned here would be stored in a bucket, or a memory location, which would be kind of a container which would storing the value of 24. Okay. That is why sometimes we used to call that as a memory bucket. Okay. Which means it is a memory location in your hard drive, where it is going to store the value of a variable declared. Okay. But in Python, that is not the case. Python, how it acts as, in Python, by contrast, variables are best thought of as pointers, not as containers. What it means is, when you write a number is equal to 24, which means number will be of a type a number or an integer. Okay. And now you are indirectly saying that you are essentially creating a pointer where it will point to the location where it is stored. What it means is, let's take this an example here. Okay. Now let's consider here. Now what will happen ideally here is you have a Python name, a variable name called number one. Okay. Which means, let's take in our example, uh, number one is a variable, or let me, okay, number one is equal to what I'm trying to store here. Number one would be storing a value of certain value. Okay. Which means name one would be called as skill. Let's do that. Okay. Name one will be called as skill. So what it is, name is of a type, name is of a type string. Okay. That is what we can see. So the name one is a variable name. It is storing the value called skill. So the type of the name one variable is string. Now let's go back to this and see what happens behind the scene in Python. So Python name would name of the variable would be name1, but behind the scene it would create a pi object which will store all these values. Okay, what are those values? It will be a type, the value, and the reference count. What it means is, what type of a variable it is? It is of a string type. What value is it storing? It is storing a skill as one value. And how many variables are referring to this pi object? There is only one. Okay, but there might also be a case like, if for example, let's say, what I'm trying to do here is name is equal to name plus zam. So what does it mean? I am concatenating here, which means name1 is getting updated. Let's do that. Okay, name is equal to name plus zam. So what is happening here? It is a concatenation. Name1 is skill. With that, I am concatenating a word called zam. So now if I see name1, what it will contain? It will contain skill zam. Okay, it will now contain skill zam. Let me clear this once again and show you. Yeah, the first one is what it contains. It's a string. Name1 now contains skill. The moment I execute this, what will happen? It will be concatenation of skill plus zam, which will be new value that is stored in name1. Okay, so what will happen here? There is some thing that it will be doing now. What it is doing, this pi object has left. It is no more pi1. Name1 is not pointing to it. Okay, which means this is a pointer to this location or the storage or the memory. It is not the actual variable that is containing it. That is the reason in Python it is referring to a memory location. That is what the pi object would specify, what type it is, what value it contains, and what is the, how many variables are referencing. For this pi object, there is now, earlier it was referring 1. Here it will now change, this will be 0, whereas this will be referring to 1, because now name1 has been modified. If you have seen this, name1 has been modified and now it is containing a value called skillzam. Now with that being said, what will happen next? Next what will happen is name1, then I am assigning this value. What I am trying to do here, let's go and put this here. Now what I'm trying to do here, now name 2. Let me restart it once again, clear the output. Okay, now the first I'll run this, it will contain skill, and then this will contain what? Skillzam. Now this will contain what? Name1 is assigned to name2 is a variable. Now it contains a value called skillzam. Okay, here one thing you need to understand here, an important thing that I want to bring here is a field called ID. Let me give that with that reference. Let's say here. Okay, now ID. What this ID contains? ID is a function in JavaScript. What this ID function would return, or a method would return, this method would return a unique identifier for a variable. It is as if like a memory location in a behind the scene. So every variable is assigned a unique identifier. That is what it will give now. What it means is, currently name1 is skill, which is at a identity level of this unique identifier. Okay, let me clear this once again and show you. Clear the outputs as well. All right, now let me run this once again and show you what will happen here. So now name1 is equal to skill. It is at the ID location of this one. which is 212694. Now let me go ahead and add name 2. Now I'll execute this. Now if you observe here, name 1 is containing skill, name 1, again I'm adding an concatenation. It is still at the same memory location. It is still pointing to a different memory location, which means this value has created another variable or a pointer which is pointed by pi object, what we saw. So now name 1 will be at a different location. Observe that this number and this identifier are both different. All right. And now let me go ahead and see. But if you observe, when I am saying name 1 is equal to name 2 is equal to name 1, which means both are pointing to the same memory location. If you observe this 212694, 8221424, so it is the same memory location now currently reserved for name 2, which means my pi object is actually now pointing to memory 1 and this one, the variable, both, which means both these variables are now pointing to the same memory location, whereas the earlier it was pointing to the different memory location because this pi object contains skill. Now this both will now contain skills there. All right. Now with that being said, so here, that is what we are pointing to. They are pointing to the same memory location. So hence this reference count will be 2 now. And finally, what will happen? Now I am trying to rename it, which means if I go here and say name 1 is equal to exam. So what is happening here? I am trying to assign altogether a different value, which means this will create another pi object. So this object will contain this value. If you see the identifier of this one now, it will be changed. So this is altogether a different identifier, which means now this identifier contains a value called workzam, but the storage is at a different location. Okay. So what we are trying to see, but this was not the case in C. When we say a name 1 is equal to, the name 1 will directly assign a storage location, not the value here. But here it is all the value. It is all about the objects, and those are nothing but the pointers. Okay. Did you guys understand this? What is happening here, guys?
Yep.
Yes, sir.
So in C, how the things would happen, name 1 is equal to skillsam. Now let's consider a C as a reference. Okay. Now in C programming language, name 1 is equal to skillsam, skill, which means name 1 will be having a certain memory location called 123 123 Okay. This might be the memory location in C. Okay. But here also it would be same because it is the same variable, so memory location won't change. And here when you are assigning this value to this variable will be created a separate memory location. It would have been this one, this name 2 would have been a separate memory location, and at the same time this would have been the same memory location here. This would have been the same because it is the same variable. All right. But in Python, what happens is every variable is a pointer. It will point to the object that is assigned. You remember that, right? Name is equal to object that we said. Everything in Python is an object. So this object is variable is pointing to an object which is pi object, which is nothing but a pointer. It is a pointer to a memory location. It is nothing but a memory location. That is the reason name 1 is having initially this value, skill, and it is stored at this memory location. And now what happens? Name1 is modified and concatenated by another value concatenated with ZAM. Then this name1 is storing at a different location from this now. It has been changed. And at the same time, when I am assigning a value to the another variable, which means I am actually pointing name2 to a memory location of name1. That is what it means. So hence name2 and name1 will both point to the same memory location now. And next, what I'm trying to do, name1, I'm assigning all together a different value, and this value is stored in pi object, which is an object which is a pointer, and this is pointing to a different memory location. Hence name1 is now at this memory location, which is changed from the earlier. Okay, understood guys, how it is varying from C programming language, which is a statistically typed, whereas name in Python, everything is a dynamically typed programming language, where the value of a variable is nothing but a pointer to a memory location. Are you understanding this concept?
Yes, sir.
Yes, sir.
Any questions guys in this?
No, sir.
Okay. Now let me try to go to the next thing, what is known as everything is object in Python. Why are we saying everything is object in Python? Let's come to that now. Before we come to that, I want to give you one understanding of is instant function. Okay, is instance. Let's take this an example. So is instance, what does this function or a method does? This function or a method is instant is a method in Python. It returns true if the specified object is of a specified type, otherwise it is false. What it means is, now is function is instance will take two parameters here. Okay, what are those? One is definitely a variable name. You give a variable name, comma, and what type of a what type it is, whether it is an object or whether it is not. Okay, now let's say if I give it as an object, whether if the name type is same as an object, then it will return true. Okay, which means name one is an object type, that is the reason it is returning true. Had it been int, if I write, it would not be the same. So because the type that is hidden behind is nothing but, or had it been a function or a, or for that matter is it a list, it will return false. This is the usage of is instant function. So what is instance function will do? This function is an inbuilt method that would return true if a variable and the specified type is matching, then it will return true, otherwise it will return false. Now in this case it is returning true. And also let me give you an example, like a deci number is equal to 3.142. Okay, and then I will write is instance of this one. Now this is a decimal type, right? It is a decimal, which is nothing but floating point number. Floating point. All right, now this will also return true. Why? Because what are we trying to say? Everything in Python is an object. That is what we are trying to come to now, conclusion. Let's take that with this example. With that background, let's go here. So Python, as you know, it's an object oriented programming language, and Python, we say everything is in program. Now we have seen that variables are nothing but pointers here. Okay, so variable names themselves have no attached type. Only when we assign a certain value, then the type of a variable is defined, then it will come out. Like for example, if we have a variable name as variable 1 is equal to 2 or 22, then the variable 1 will become a type of integer. Okay, now uh, but if you observe here, stock price is equal to 112, so the type of this is integer. Okay, it's a type of this is an integer. And INR is Indian rupee, which is a string. And then there is a dollar US 82.282, which is the exchange rate for US dollars, which is of a float. Now, what is instance we have seen is a function return true if the specified object is of a specified type. Now, what are we trying to do here? Even though its type is integer, it is still an object as well. That is what we are seeing here. Stock type, which is defined here, stock price is equal to 112. And if I give is instance an object, it is returning the value true. Even though stock price is of an integer data type, it is also a object type. Okay. And at the same time, INR, which is Indian rupee, we have seen this as a string. String is also an object type. That is the reason it is still returning true. And so is the case with floating point, and it is returning true. So what are we trying to say and conclude here? What we're trying to say is Python has types. However, the types are linked not to the variable but to the names that an object file specified themselves. Let's take here another example. Now, if I give a variable name as let's use the same variable name, which is called as INR. INR is equal to, now let's, if we use this just INR and execute this, okay, it will return an error. What does it will say? Name INR is not defined. So how are we going to define? The moment we assign a value to it. Okay, the variable, this is a name, and the value is nothing but an object type. We'll see how is that an object type. Let's say if it is a say Indian rupee. All right, now it is fine. Now the same Indian rupee, right? If I go ahead and say INR dot, so if I put INR dot and tab out, you will see lot of properties here. So understand that every object that we saw, that we create in you might have seen in JavaScript as well, right? An object contains what? Key value pairing, right? Like if I go ahead and show you uh, in console, let me go and show you in console. I'll move out. Okay. Now let's say const uh, user details, DETAIL. Now what I'll show, it will contain a object. Now this might contain what? Key is equal to maybe UID is equal to let's say what I can give, UID is equal to 123. Okay? And then I can say let's say gender is equal to male. All right. Now what does this contain? Or maybe what I can say, yeah, just a second. Okay, now if you see, we can also go ahead and define function as well. Like for example, uh, get get date of birth equal to, then what we can go ahead and say, it might be a function which will contain some value, and this will contain certain value, say to contain certain value. Maybe it is returning a value called as 12 12 20. It is returning this value. Now this is nothing but an object. User detail is an object here. Okay. User detail is an object. It contains key value pairing. There is a key, there is a value, key, value, key, value. And key can be always, keys are always strings, and values can be of any data type. It can be a string, it can be a number, it can be a string, or it can be a function as well. Okay. So what it contains is, in JavaScript, a object might contain properties, and these properties always appear in key value pairing. And whenever I want to access a value from an object, what I'll do, I'll give a variable object name dot uid will give me this value. User detail dot gender will give me male. That is how I access the value of those individual objects or the properties. In the same way, when I type INR dot and then tab out, what you get is these properties. Some are straight away a simple attributes, whereas some are nothing but methods. Like for example, if I say is lower, very very common, is lower, and this is nothing but a method. It is a method because this has got a open and close parenthesis. If I enter this, what if I enter this, what will it give? INR is lower, which means it is saying this is not lower because it is containing capital and small. Okay, and hence it is returning the value called false. And at the same time, if I go ahead and say dot tab out, there is also something called as lower, just lower. What it will do, it will convert everything into smaller cases. This will return certain value of the string. So now this is also a method because open and close parenthesis. All right. There are lot of attributes and methods are associated with this object. All right. So the string will be an object. That is the reason when the string is assigned to a variable, this variable name is now treated as an object. That is the reason this variable name dot, when you see, you will get lot of attributes and methods that you can associate with this object now. Okay, so what it says, it justifies that in Python everything is treated as an object. This is just not about only the integers that we are talking about. If it can be a decimal number as well. Like for example, if I go decimal float number dot tab out, it has got its own properties as well. Okay, now it can be like, if you want to get a real number or is integer, whether it is an integer or not, you can go ahead and see. uh, this can be easily, it is not an integer because it is a decimal number with a value of 1.3.142. So what we are trying to say here is, everything in Python can be treated as a object. That is the reason, if you observe this particular statement here, in Python everything is an object, which means every entity has a metadata called attributes and associated functionalities called methods. That is what we saw here. If you see, these are the attributes and methods that are associated with the data type decimals. Okay, these attributes and methods can be accessed via dot syntax. This is what the dot syntax is. The variable name dot something. All right. And that is the reason, if you see here, there are a lot of things here. Some examples. A list is nothing but an ordered sequence of data. Again, we'll come to what list is, which can be given by a open and closed parenthesis, square brackets. And this we'll come to know very soon when we are dealing with some compound data types or data structures in Python. We'll see that what are lists, what are tuples, what are dictionaries and sets, and so on and so forth. But now, for the time being, just understand that this is a list. List contains primary numbers, which is the ordered sequence. So this has an index at 0, 1, 2. All right. And now prime numbers dot append at 7, what it will do, it will append the value at the end, which is which where the now the prime number will become 2, 3, 5, and 7. Okay, which is what we are seeing here. All right. And print the prime numbers. And is instance prime number, is it an object? Yes, it is an object. That is the reason it is returning true. All right. It is just to show that different kinds of data types, whether it is a primitive data types like numbers, integers, floats, and all that, or it might be very compound data structures like lists and lists, tuples, and all other things, and they also are object. Okay. Now, and there are many examples that we have taken. How about the complex numbers? If we have a complex numbers, it is also will be an object type. And if it is a floating point number, it is also will be an object type, true. And even if you go ahead and see the Boolean as well, they are also of a similar object data type, because what we can see here is these instance, and go ahead and give, right, this also will return the value true. Okay, because is greater, now is greater, if I see type of, it is a boolean bool, you will give a bool value to it. So it is a class of bool. Okay, it is a bool class. And now even this is of an object type, that is the reason it is showing true. So everything in Java, in Python, is a object. All right, that is what it justifies. Are you guys clear on this concept, guys?
Yes.
All right, good. Now let's go ahead with the next topic to understand what is called as operators. Okay, there are different kinds of operators in Python. All right. And we have seen those operators in other programming languages prior to this. We have seen in JavaScript there are arithmetic operators, there are assignment operators, comparison operators. We also saw there as a logical operators, and also bitwise operators. In the same way, even Python has got the similar set of operators like arithmetic operators, bitwise operators, assignment operators, comparison, Boolean, and identity and membership operators is something very different. We'll see that as well. But for now, let's begin to understand what are these arithmetic operators. So if you go ahead and see, these are the set of arithmetic operators. A plus B, obviously sum of A and B, subtraction, multiplication. There is a true division, and there is a floor division. This is something extra. We'll see this with an example. We have seen mod A mod B, it is nothing but it will give the remainder when A is divided by B. And A star star or asterisk asterisk B is nothing but exponentiation, which is a power of, like A to the power of B. And a minus A is unary negation, or nothing but a negative value. And unary plus, which is nothing but a value of any number, which is obviously plus is assumed. Okay, that is the reason it is a unchanged or a rare value. Let's take this consideration. What is the difference between true and floor? Okay, let's see that. So now let's take this example, guys. What the very same example. Let me. Oh, where is that? Yeah, it might not be here. Let's see. Now let's take pi value. What is the pi value? Pi value is 3.142. Okay, that is what pi value is, right? Now let's assume this pi value is equal to 22 divided by 7. So what we are trying to do, this is nothing but a simple division. Now when I execute that, now what my pi value will contain, let's see that. Pi value will contain a decimal or a floating point number with 15 decimal places. Okay, 1 2 3 4 5 6 7 8 9 10 12 13 14 15. That is the max 15 decimal points you can see. Okay, this is nothing but a normal simple division. Okay, the operator that I'm trying to use is front slash. Okay, either with spaces or without spaces, as white spaces are immaterial here. All right, now this division will give me a floating point number. Now if I don't want these decimal places, that is when I do floor division, which is nothing but you will write two double forward slash with the same thing. Now the output will just be 3. Okay, so what it will do, floor division will remove all the decimal places, whereas a normal division will give you the decimal places. Even the integer is, both the values are integers, they are not floating point here, but the resultant will be a floating point. This is called upcasting. We usually say this as upcasting because you are changing the integer values to the next higher value, which is a floating point number. This is called upcasting. Okay, now this is what will happen. 22 by 7 will give you a decimal number or a floating point number with 15 decimal places with double forward slash, which is nothing but a floor division, which will give you only an integer value without truncating all the decimal places. Understood, guys, the difference here?
Yes.
All right. Now, rest all, I know it is very understood. Like for example, you have a plus b will give you that value. Like for example, 12 plus 12 will give me what, 24. 12 into 12 will give me 144, and all that. Okay, 2 star star 3 will give me 8, which is 2 to the power 3. So all those are called arithmetic operators. And also 32 mod 2 will give me 0 because 32 is a even number. This is the best example to see, check whether a given number is even number is just divide the number, get the mod of that number with the 2. If the remainder is 0, then the number is even. If the remainder is 1, then the number is odd. Okay, that is a valid use case that we have seen. Now let's go ahead and understand another important here. You might have not seen, that is nothing but at symbol. So why is this at symbol? A at the rate b, what it means, it is nothing but a matrix product. So you might have seen the matrix, right? In a simple mathematics, you might have seen there is a matrix 2 by 2 matrix, 3 by 3 matrix given. The matrix, this product of the matrix you can find out by at symbol, at the rate symbol. So let's take that an example. Now, what I'm trying to do here is import NumPy. NumPy is again another a module that you have in Python, which will help you in a lot of mathematical computation. And I'm importing that as the NP. Now, matrix says np dot matrix. You will create a matrix based on this method. Okay, this is an object that is from the NumPy module matrix. Then you give within the quotes 1 2 and 3 4, which will create you a matrix like this: 1 2 3 4. And at the same time, matrix b would be created with these values 5 6 7 8, and the product of these two can be done by using at symbol. Okay, which means you are multiplying matrix a into matrix b using at the rate symbol. Okay, now this will give me the value of the product of two matrices. Like for example, how we used to do a horizontal row and vertical column of the B. 1 into 5, 2 into 7. You sum it up, then you will get 19. So how it is? 1 into 5 is 5, and 2 into 7 is 14. 14 plus 5 will give me 19. That is the value. And then you go ahead. 1 into 6 will be 6. 2 into 8 is 8 to the 16. 16 plus 6 is 22. This is what 22 is. So that is how you do a matrix multiplication. All right. So understood, guys, how this is also an arithmetic operator at the rate symbol, which will be for matrix product. Okay, make sense?
Yes.
So now,
Yes, sir.
yeah, any questions?
No, sir.
Okay. And the next one, what we are going to see here is bitwise operators. So now, bitwise operators are the operators that you are going to use on a binary numbers. Okay, these are very directly related to binary numbers to perform a bitwise logical operations on integers, which whose values are converted into binary. All right, let's take that example. A and B will be bitwise, and bits defined in both A and B. A or B, bits defined in A or B or both. A, this is a caret symbol, which is nothing but XOR, where we have A or B but not both. And then you have a left shift. Okay, this is a left shift. Okay, and then this is a right shift, and this is a negation. Tilde is a negation. We'll see this example now. Okay, now take this example. Here you have a value here. Let's take this example: A or B. A value is 9, B value is 10. So if we write that into a decimal number, how in a binary number, it will be 1001. This will be the value of 9. I have taken a 8-bit here. This is 4-bit, and this is 4-bit. And this value of 9, if converted into binary, would look like this. And the value of 10 would be this one, which is 1010. This is the value of 10. And I have there are some zeros because it is a 8-bit number that we have taken. Now A or B, what it will happen? A or 1 or 0, then the value is 1, because either of them are true, then it is true. Okay, that is the reason. 1 or 0, then it is 1. Any one, if there are two values, right, if any of those is true, then the value is true. That is how it is. If you remember or tautology, right, where you might have seen in logical case, where you are going to use an or operator, you will be, if there are two inputs A and B, if A or B, then whenever either of these values are true, then the resultant will be true. That is the operation here. 1 or 0 is all is 1. 0 or 1 is 0. If both are 0, then nothing will happen, it will be 0. If both are 1, then it is 1. For the rest of the cases, it is 0. Then this value 1011 is 11. Okay, so which is nothing but this will be 11, and the resultant will be 11, which will be converted into integer. All right, are you understanding it? Because the operation is done when the integers are converted into the decimals, integers are converted into the binary value, and then the or operator will be performed, and the resultant will be converted back to the integer and shown to you. The same case is with this value. And if you want to convert this into integer, or if you want to convert any integer into a binary, you can do that by using a function or a built-in method called bin. Bin will convert any integer into a binary. Like for example, bin 11, if you see what it will return 0b will indicate always 0b will indicate that it is a binary number, and then followed by the digit which is 1011. 1011 is nothing but a 11. That is what we saw. Where is it? 1011 is nothing but 11. Okay, that is what we are going to see here. So this is how you are going to use the bitwise operators. And even the case, it might be and, or, and all other functions, you can do the same thing. Like for example, um, 2 and 3, what will return? It will return 2. So if you go ahead and see what the value of 2 will be, it will be 0010. The value of this will be 0011. And if you going to AND it, what will happen? This value will be this, and this value is 0. This and this, the value will be 1. And this, the value is 0. And this value is 0. So what it contains now, this will be, if you AND both of them, 0 and 1, it is 0. If both are 1, only then the resultant will be 1 in case of AND operation. So 1010, if you convert that into binary, into decimal, it will be 2. Okay, that is what you saw here. This 2 is this 2 same. Are you getting are you getting this, guys, how this is done?
Yes.
All right. The next is an assignment operator. Assignment operators are the similar ways that we are seeing, but only what you get is a equal to operator. There you will have an equal to operator. Like for example, uh, 20, if you want a value, let's say num1 is equal to 12, and suppose I want to add 15 to the same value. So how am I going to do that? I can do is num1 is equal to num1 plus 15. So what this will do, this will convert num1, then this will return the value 27, which means 12 plus 15 will give me 27. Okay, but the same thing can be written, the same thing what is written here can be written as plus equal to 15. All right, this is same as writing this. What it means is num plus equal to, which this is a assignment operator, addition assignment operator. You are adding it. You are adding the number plus the value what is given here 15. So this will still be equal to 27. The same is the case when we go ahead and use, let's say if I want to minus it. Okay, it is same as num1 minus 10. It will return me the value of 2. Okay, this is in case of subtraction, and it can be the same case in terms of multiplication as well. It will return the value 120. And same is the case if you go divide, which will be 1.2, which will be same as 1.2. So these are all what we see as assignment operators. There are many things. This is add and equal to will be addition. This is a subtraction. This asterisk, if you give, it is a multiplication. There is a division. There is a floor division. There is exponentiation. There is a modulus or mod and ampersand. Now from here, there is also a bitwise assignment operators. A and B is nothing but A is equal to A and B. This is what it means. You are doing a bitwise and bitwise or nor left shift right shift. And even what does this left shift and right shift do? It will shift by so many. Like for example, let me give one example here. The same thing. Let's take uh, you are trying to left shift by 1. So what you are doing, you are taking 2 and you are doing a left shift by 1, which means your 1 will move here now. So if I go ahead and run that, it will become 4. What is this resultant will be? This resultant would be like you have got what 1 here. Okay, so you are trying to move that by one place, which means the value will be equal to 0, 1, 0, 0. So you are moving this value one bit here, one bit on your left side. So this value, which is 2 to the power 0, 2 to the power 1, 2 to the power 2 is 4. That is the reason you are getting the value 4. This is nothing but the binary representation of the integer 4. You are doing a left shift of 2 by 1. Okay, and the same is the case with if you want to do left shift right shift by 1. What this will do, this is your number 2 and you are trying to do a right shift by 1 bit. So which means here your 1 will come here. Now it will be 0, 0, 0, 1. You are moving on the right side. Now the value will be equal to 1. So that is the reason you are seeing the value as 1. So do you understand, guys, what is left shift and right shift?
Yes.
Yeah, when you are using this shift operators, all right. That is what we are trying to do here with a left shift and right shift. The same is the case when we do a left shift and right shift in your bitwise operators as well. Okay, so what it means is shift the bits of a left by b bits, b units. This is b, this is b. We have given 1 1 here in our example. All right, and now with the assignment operators, and then there is also called as comparison operators. Always whenever you do a comparison operator, it will return a boolean value. Okay, always remember this. So it will, whenever you compare, it is always returns a boolean value, true or false. And some examples are a is equal to b, a not equal to b, a less than b, greater than b, less than or equal to b, and all that. So let's take this example. 25 less than or equal to 35, which is true. Then now because of this, it will return either true or false. This is the operator, comparison operator. You are comparing the left with the right. So whatever it returns is a true or false. It will, comparison operators will always return true or false. Like for example, 25 is equal to 25, which is absolutely true. Then that it will return the value true. And then 25 less greater than or equal to 55, which is false. Hence it is return the value false. Okay, and 12 greater than 13, which is false, hence it will return the value false. So these are nothing but the comparison operators. They always return the value, boolean value, true or false. Okay, and most of the times these comparison operators are used in decision making, like if conditions, while conditions do. So those kind of conditions we would be using them. Like for example, if 25 is greater than 55, then I'm trying to do something. Let's say print 25 is greater than 5. Print 25 is greater. Okay, so now this is how you are going to use them. Okay, unexpected indentation. All right, let's give this indentation. Delete syntax. Okay, so now what it is saying, if 25 is greater than 5, print 25 is greater. So obviously this condition is true, then you are going to print this. All right. So whenever you do have a if condition or elif condition, so you are going to use these comparison operators very often in that context. And there is also something called as Boolean operators. Boolean, as the name itself suggests, whether it will return the value true or false. And what are those operators? They are and or not. So these operators use and or not. These are called Boolean operators, and and they will have the similar impact. Like for example, what it says: test number is equal to 11, and if the test number is less than 15, which is true, and test number is greater than 10. So when both are true, then the and will be true. Okay, that is the reason you are getting true. And test number is greater than 9, or mod 2 is 0, both are true. If either of them is true, then this will be true. Okay, this or this. Now in this case, what happened? 11 mod 2 will become false here, because it won't be 2, it will be 1 here, because this is an odd number, right? Odd number will return 1. Hence, this will be failing. This is false and this is true. So either of them is true, then it is true. So this will return true. Not is kind of a negation. Whether test number is what? Is 11. 11 is less than 7, which is false. So the false will be negated and this will return true. Okay. This will be what? This will be false and this will return. And at the same time, you can go ahead and say not false. Okay, not false. What it will return? It will return true. Okay, it is, that is what we did here. That is what we did here. Not false is true. All right. And then there is a identity or membership. Okay.
Excuse me, sir.
Yeah, yeah. Go ahead.
Sir, can we say both the comparison operators and as well as a Boolean are same?
No, but they are not the same. They are not the same. Why? Because comparison operators have got a certain different working. It is like you are comparing two values, and here the Boolean operator, what they are doing, you are using those comparison operators and again you are testing them. Okay, when working with Boolean values, right, Python provides operators to combine values using standard concept and or not. Okay, here what you are doing, now suppose there are two conditions here. Okay, what are the condition? Test number is less than 50, test number is greater than 50. And if you want to see both are true, then how are you going to give in a programming? You need to utilize the Boolean operators. Okay, but in the same way, if you remember, in Python, in JavaScript, there was something called as logical operators, right? If you remember.
Yes, sir.
So if you go to go here, like for example, 25 greater than 23 greater than 10, and 12 less than 24. So what is this doing? This is a comparison and this is a comparison, whereas this is a logical operator. Logical operator with ampersand ampersand. This will be true. In the similar way, what the logical operator does, here the Boolean operator and does the same thing. And if you remember, there was also an operator called logical or operator with two pipe symbols. This is similar as or operator in Boolean. And also, if you remember, there was an exclamation which was saying 25, 23 less than 20 32, which is true. If I give it as 20, which is false, this is false, and negative of this is true. Hence, exclamation will be acting as what? The same thing as not here. Okay, this exclamation is same as not in Python. Are you getting this?
Yes, sir. Followed it.
Okay, so this and or and not are called Boolean operators in Python, which are of a similar usage like we do a logical operators in JavaScript, like ampersand ampersand, pipeline pipeline, and also exclamation, which is representing the not. Okay, and last for today, which is called identity and membership operators. So what they are very specific, like and or not. Python also contains pros like operators to check the identity or membership. So what is this? A is B, which means A true if A and B are identical objects. Okay, identical objects. A is not B, true if A and B are not identical objects. A in B, true if A is a member of B. Okay, A is not in B, which is true when A is not a member of B. Let's take that an example. So identical operators, right? Identical operators is and is not, whereas membership operator is in and not in. Okay, so that is the difference. Now identical operators, let's take with an example here. uh, there is a list here: odd number 1, odd number 2. So both are similar. Three contains values or elements called 3, 5, 7, and 3, 5, 7. Odd number is equal to odd number 2 is obviously both are true. And then odd number 1 is odd number 2, which means A is true if A and B are identical. Now, if you observe here, it is not. Hence, this is returning false. Why is that? Why is this giving this? And if you say is not, then it is returning true. Why is this? Because this storage and this storage are in a different pointers. They are pointing to a different location. Now for example, if I see the ID of num1 and then you say ID of num2. Just a second. Print. So if you see here, this num1 is at this memory location and at num2 is at a different memory location. So both are pointing to a different pi object. Okay, the storage is altogether different and they are altogether a different in their identity. Hence they are not the same, even though the value they contains are same, but they are not identical. But if you see here, even number 1 is this value and then the number is assigned to the 2. So if both are true, yes, because both are identical to each other. If I say print ID of num1 and print ID of num2, and if I go ahead and do that, both are same. They are identical. They are pointing to the same ID, same memory location. Hence they are called as identicals. This is where num1 is num2 will be true. Okay, this is where num1 is equal to num2 will be true. That is the reason you are getting the value true here, whereas in this case it is not. It is not true. Num1 is or number 2 is false. Okay, this is how you see the identical operators being tested. Now there is also called as membership operators, which will be for the compound objects. Like in this case, this is again we are trying to check messy in this, whether this value is contained in this. Yes, true. Whether messy not in this is false, because it is there. Okay, this is what the membership operator checks for the membership within the compound objects. What does it say? A in B is true if A is a member of B, is a part of B. Okay, that is what we saw here. Messy is a part of this list. Okay, so understood, guys, so far? So that sums up all the operators today. And tomorrow, right, again, we'll go deep dive and try to understand other things. And see you tomorrow. Any questions, guys, so far? Any questions do you have?
No, sir.
No.
Okay. So tomorrow, right? We'll again regroup tomorrow at 9 and try to understand again some important topics. Okay. Yeah.
Sure, sir.
Thank you. Thank you, guys. You guys have a good night.